Section 1, Introduction. Welcome to Confined Spaces, the Basics, Part 1, Hazard Awareness. This is the first part of a three-part course that will educate you on confined spaces. Part 1, Hazard Awareness, covers how to recognize confined spaces and the types of hazards that may be present. Part 2, Hazard Control, covers how to control the hazards. Part 3, Working Safely, covers proper ways to enter and work in a confined space, as well as emergency planning. At the end of each part, there is a test to check your understanding of the material. Confined spaces can be deadly. Each year, confined space accidents claim many lives. Over 60% of the deaths in confined spaces are rescuers. Read these real stories to see why learning about working safely in confined spaces is so important. 1. Father and son die at wastewater plant. 2. Worker dies inside storage tank. Rescuer dies, 15 injured. 3. Worker dies in sewer line. Rescuer dies, 38. Top reasons people die in confined spaces. Inadequately trained to recognize a confined space and the hazards that may be present. Mistakenly assumed that their senses would detect a toxic atmosphere. Did not realize toxic gases are usually invisible, tasteless, and odorless. Intended to only go in for a minute. Unaware of, or forgot to, watch for hazards that can develop during work in a confined space. Attempted to rescue coworker in trouble, but was not properly trained and equipped to do so. Root cause in all cases, insufficient training. Objectives of Part 1, Hazard Awareness. By the end of Part 1 of this course, you will be able to explain your duties and responsibilities, describe the characteristics of a confined space, list the types of hazards found there, appreciate that hazards can change rapidly. Note, this e-course will help you meet legislated requirements for education and training in health and safety. In addition, you will need instruction specific to your worksite conditions and procedures. To be fully trained, the three parts of this e-course provide the classroom learning portion of a confined space program. To be fully trained in confined spaces, you also require specific hands-on training and practice, including specific entry and work procedures for the confined spaces you will work in, gas testing and air monitoring equipment and procedures, rescue equipment and procedures, any personal protective or safety equipment required for your work. You must receive this training at your worksite from experienced trainers. Section 2, Ask a Question. If you have any questions about Confined Spaces 1, Hazard Awareness, that are not answered by this course, you can start by checking the OSH Answers section of CCOHS's website. If you do not find the answer to your question there, follow the link to Ask CCOHS. CCOHS staff will respond to your question by email within 2 business days. CCOHS is open Monday through Friday and closed on Canadian public holidays. Section Section 3. Responsibilities. Responsibilities of employers, supervisors, and workers. Everyone is responsible to ensure that work in a confined space is done safely. The employer is legally responsible to make sure that work is done safely. Workers are informed of hazards. Workers are appropriately trained. The employer must take all reasonable precautions for the safety of workers at all times. Make sure that the organization complies with all applicable confined space regulations and other relevant legislation. Appoint competent supervisors. Develop a written confined space program, CSP. Provide and maintain all necessary equipment, including personal protective equipment, PPE. Ensure proper use of the equipment. Supervisors. A person who supervises confined space work must be fully trained and experienced in all aspects of confined space work, knowledgeable about hazards, necessary precautions, and safe work procedures. The supervisor is responsible for identifying all confined spaces, ensuring appropriate space preparation including pre-entry testing, informing workers of actual and potential hazards, making sure workers and contractors involved with confined space work are thoroughly trained, equipped, and follow safe work procedures, allowing only authorized workers in the space. Follow the link for the exception. Workers. Workers must be aware of hazards and notify their supervisor of any health and safety concerns. Be thoroughly trained in proper confined space entry and emergency procedures. Follow specific safe work procedures. Not work in a manner that may endanger lives. Be fully trained to use the required personal protective equipment and other safety equipment. Contractors must follow the employer's confined space program and plans for the specific confined space. Be trained in confined space entry and safe work procedures before working in a confined space. Raise any health and safety concerns with the on-site supervisor. Note, the employer is ultimately responsible for contractor health and safety. Quiz. Select the answer you think is correct, then submit. What do you think? An employer trains workers in confined space by telling them to read a document and asking them to sign a form that indicates that they have read and understood the material. This employer fulfilled his/her duties. Section 4. What is a confined space? Which of the following are confined spaces? Sewers and storm drains, pipelines, tunnels, silos, process vessels, boilers, double hulls, manholes, manure pits, water reservoirs, storage tanks and bins, tank cars, pits, sumps, vaults, digesters, pumping stations. Follow the link for the answer. Definition of a confined space. A confined space is an enclosed or partially enclosed space that is not designed for continuous human occupancy, has restricted entries or exits because of size, location, etc. Can be a risk to people working inside because of its atmosphere, its design, construction, or location, the hazardous materials or substances in it, the work activities being done, the mechanical processes and safety hazards present. What do these phrases mean? Enclosed or partially enclosed space. An enclosed space is any area surrounded on all sides, bottom, and overhead. A partially enclosed space may have limited openings on the top or sides. Ask yourself, does the space have limited or restricted means for entry or exit, such as you have to crawl, climb, twist, or exert unusual effort to enter or exit? There are obstructions such as bulkheads, machinery, narrow passages, or openings. Is the space designed for continuous worker occupancy? Ask yourself, was the space designed and built according to the building code for ongoing work activity? Confined spaces are not built for continuous human occupancy and are typically only entered occasionally for work such as inspection, maintenance, repair, or construction. Spaces designed for frequent or lengthy occupancy, such as machinery and boiler rooms, have doors or other easy points of entry and exit, adequate lighting, and sufficient ventilation to ensure a safe atmosphere. These would generally not be considered confined spaces. Confined spaces can be above ground or below ground, can be small or large. The legal definition of confined space can vary from jurisdiction to jurisdiction. You should review the laws that apply to your worksite. Identifying a confined space. Before entering an enclosed or partially enclosed space, which is not normally occupied by people, ask yourself, is this a confined space? Is it designed to be occupied by people? Are the entries or exits difficult to get through because of size, location, etc.? Is there the potential for someone working inside the space to be in danger because of its atmosphere, design, construction, or location, the materials or substances in it, the work activities being done, the mechanical processes and safety hazards present? If the space is not designed to be occupied by people and has restricted entry or exit, and if you answered yes to any of the questions about risk, then you are likely dealing with a confined space. Raise your concern with your supervisor. Confined spaces need a plan for safe entry. Work plans must be developed and suitable precautions taken before entry into the space and before any work is done. Identifying confined spaces can be complex and difficult to do. This course cannot cover every situation. You may need to consult with a confined space expert or your jurisdiction for further assistance. Exercise. Is this a confined space? You are assigned to do some repair work which involves welding inside an empty above-ground storage tank that up until yesterday held 100,000 liters of gasoline. Is this storage tank a confined space? What were your answers? Is the space enclosed or partially enclosed? Yes. Is it designed for occupancy by people? No. Are the entries or exits difficult to get through because of size, location, etc.? Yes. Is there the potential while working inside the space to be in danger because of its design, construction, location, or atmosphere? Yes. The materials or substances in it? Yes. The work activities being done? Yes. The mechanical processes and safety hazards present? Yes. Answer. Is this a confined space? Yes. This gasoline storage tank is a confined space. To work in this space, be sure you have followed the key steps to safely entering and working in the space as discussed in this course. Quiz. Is a pit or well that has an open top a confined space? Section 5. Common activities in confined spaces. What kinds of work are commonly performed in a confined space? Do you perform these or similar tasks in confined spaces? Inspection processes including checking meters and gauges, cleaning to remove sludge and other waste materials, maintenance and repair work such as abrasive blasting or application of surface coatings, installing, inspecting, repairing, and replacing cables, valves, piping, etc. We will examine the hazards of these activities in confined spaces. Section 6. Hazards in confined spaces. Why can working in a confined space be especially hazardous? Conditions in confined spaces can change quickly. You cannot always predict the changes. The restricted entrance-exit of the confined space might not allow you to get out quickly if there is a dangerous situation. Rescue is more difficult. The interior design of the space often does not allow for easy movement of people or equipment within it. Natural air movement alone will usually not be sufficient to maintain good breathable air. Conditions outside the confined space can affect the confined space and vice versa. Work activities may introduce hazards not present initially. Remember, Working inside a confined space is more dangerous than doing the same job outside of a confined space. You must know and follow the correct work procedures in order to work safely in the space. In confined spaces, you must expect the unexpected. Types of hazards. There are 4 major types of hazards in confined spaces. We'll look at each type in detail. 1. Atmospheric hazards, such as flammable and toxic gases. 2. Release of hazardous energy, such as electrical and mechanical hazards. 3. Engulfment hazards from materials, such as grain, coal, sand, and water. 4. Other hazards that include slips, trips, falls, temperature extremes, noise. Section 7. Atmospheric hazards. Atmospheric hazards include 1. Oxygen deficiency, a common killer. 2. Fires from flammable gases and vapors. 3. Toxic materials. Atmospheric hazards are a special problem in confined spaces because many gases and vapors are invisible, tasteless, and odorless. Your senses cannot serve as an early warning system. Conditions can change very quickly and without warning. Oxygen deficiency, too little oxygen, is the most common concern, so let's look at it first. Section 8. Atmospheric hazards, oxygen deficiency. The air that we breathe contains a mixture of different gases. Oxygen makes up 20.9% of normal fresh air. In confined spaces, oxygen deficiency is defined as a level less than 19.5%. Serious health effects occur below about 16%. It is important to continually monitor the oxygen level when people are working in a confined space, as you cannot rely on the symptoms of oxygen deficiency as a warning sign. People in this situation cannot rescue themselves. Causes of oxygen deficiency. There are 2 main causes of oxygen deficiency. 1. Oxygen is used up by some activity in the space, such as biological action, rotting leaves, decaying organic matter, oxidation processes, rusting metal, welding, cutting torches. 2. Oxygen is pushed out or displaced in the space by other gases. Another gas accumulates because of the location, for example, carbon dioxide because it is heavier than air. Inert gases used to purge, clean a space, for example, nitrogen, argon. Inert gases. Inert gases are commonly used as a safety precaution, but they can be killers. As a safe work procedure, inert gases such as nitrogen are used to purge confined spaces and remove other hazards, for example, explosive atmospheres. If you enter a space full of nitrogen before it has been ventilated and without suitable respiratory protection, you will lose consciousness almost immediately. You will be dead within a few minutes. Many lives are taken each year in this way. Follow the link to read more about the hazards of nitrogen. Oxygen deficiency, case reports. Read how too little oxygen created deadly situations from rusting equipment, using an inert gas. Quiz. Select the answer you think is correct, then submit. The human body can sense low levels of oxygen, so workers have adequate warning of atmospheres with too little oxygen. Quiz. Select the answer you think is correct, then submit. How can nitrogen be dangerous in a confined space? Section 9. Atmospheric hazards. Flammable atmospheres. Flammable conditions are a serious concern within confined spaces. They are the cause of many explosions and fires causing injuries and loss of life. Flammable conditions are created by flammable and combustible materials, fuels, in the air. Vapors, for example, gasoline vapor. Gases, for example, methane. Aerosols, for example, sprayed paints. Dusts, for example, flour. The fire triangle. A fire or explosion happens when a combustible material, fuel, in the presence of air, oxygen, is heated to its ignition temperature. These three elements are described as the fire triangle. Fuel, for example, the flammable or combustible material. Oxygen, for example, the oxygen present in air. Source of ignition, for example, a flame or spark. To have a fire, you need all three elements present. Flammable range. Flammable gases and vapors can readily be ignited and burn or explode when the fuel concentration is in the flammable range, between the lower explosive level, LEL, and the upper explosive level, UEL. Flammable ranges vary. Some common materials can be seen here. Below the LEL, the fuel-air mixture is too lean. There is not enough fuel to support combustion. Above the UEL, the fuel-air mixture is too rich. There is too much fuel and not enough air to support combustion. Flammable gases and liquids. Some examples of flammable gases include methane, which occurs naturally and has caused many explosions in coal mines. Propane. Hydrogen, which forms during battery charging and has caused explosions when the gas accumulated in a charging room. Flammable liquids like gasoline readily give off enough vapor to create a flammable atmosphere. Quiz. Select the answer you think is correct, then submit. Air testing indicates that the flammable concentration inside a space is above the UEL. It is safe to work in the space since the concentration of flammables is not in the flammable range. Combustible dusts. Flammable atmospheres can also be caused by combustible dusts. Workplaces that produce a fine dust such as grain, flour, wood, coal, or plastic dust must control these hazards. If the concentration of combustible dust in the air reaches a critical concentration, then all you need is a source of ignition to cause a vicious explosion. Follow the link for more information about combustible dusts. Too much oxygen. We discussed earlier that too little oxygen can be hazardous to the health of workers. But did you know that atmospheres can also be dangerous if there is too much oxygen present? Too much oxygen enrichment occurs when the oxygen concentration is greater than 23%. Although oxygen is not flammable, its presence allows other materials to ignite and burn easier. Excess oxygen also increases the flammable range of gases and vapors. Fires in oxygen-enriched atmospheres burn very fast and with great intensity. Oxygen enrichment. How can you get too much oxygen? Oxygen has leaked from an oxygen cylinder or oxyacetylene torch. A space is accidentally ventilated with pure oxygen instead of air. Remember, pure oxygen is not the same as fresh air. Pure oxygen is 100% oxygen. Fresh air contains about 21% oxygen. Always ventilate a confined space with fresh, clean air. Section 10. Atmospheric hazards, toxic materials. These make up the final group of atmospheric hazards. There are many kinds of toxic materials and many kinds of toxic effects. The most common toxic materials encountered in confined spaces will be discussed here, but they can vary depending on the workplace and the industry. Always know what you could be exposed to. Toxic atmospheres. A toxic atmosphere can contain dust, mist, and fumes, vapor, and gases. The atmosphere is toxic if the levels of toxic materials in the air exceed the exposure limit. Some adverse effects, such as irritation, coughing, and unpleasant odors, may be experienced even if the exposure limit is not exceeded. Toxic chemicals. Chemicals can only cause health effects if they can enter the body through inhalation, skin contact, or ingestion. To protect yourself, you can use control measures to eliminate or reduce exposure by removing the chemicals from the worksite air, applying safe work practices and procedures, properly using appropriate personal protective equipment. Follow the link for more information about how chemicals can enter the body. Sources of toxic atmospheres. Toxic atmospheres in confined spaces may arise from bacterial action on organic material, for example, hydrogen sulfide, materials stored in or leaking into the space, for example, gasoline from a leaking underground tank, emissions from work being performed in the space, for example, paint, solvents, welding fumes, emissions from work in areas close to or connected to the space, for example, carbon monoxide from a nearby heater. Examples of toxic atmospheres. Bacterial action in decomposing organic material produces methane or hydrogen sulfide, for example, sewers, manure pits, and uses up oxygen. An empty storage vessel often has residual material, for example, vapors trapped inside. Sludge at the bottom of storage vessels may release toxic substances released from work being done in the space include spray painting, solvents, cleaning, degreasing work, solvents, ammonia, repairing, adhesives, cleaners, welding and cutting operations, carbon monoxide, metal fumes. Toxic substances released from nearby activities include a vehicle idling near the air intake for the ventilation system, carbon monoxide, chemical storage or handling, diverse chemicals. Read case studies about spray painting and repairing a tank. How do I know if the air in my confined space is toxic? There are ways to measure the contaminants in the air. This will be covered in Confined Spaces Part 2, Hazard Control. Always keep the concentration of the contaminants well below their exposure limits. Exposure limits represent the level that is believed nearly all workers can be exposed to without adverse health effects. Exposure limits do not represent the line between safe and unsafe exposure. Therefore, the best strategy is always to try to eliminate or minimize exposure as much as possible. All Canadian jurisdictions have set air contaminant exposure limits. Chemicals can have multiple hazards. A chemical can have more than one hazard. For example, carbon monoxide and hydrogen sulfide are both toxic and flammable gases. Usually, however, toxic effects are experienced at lower concentrations, far below the levels that are flammable. It is not enough to make sure there is no flammability hazard. You must also check for toxicity hazards. You must check for all hazards. For example, carbon monoxide, lower explosive limit, 12.5%, 125,000 parts per million. Exposure limit, 25 parts per million. Common toxic gases. Let's discuss two toxic gases that are commonly found in confined spaces as examples. Hydrogen sulfide, carbon monoxide. You need to test for these gases because they can have serious health effects or may cause explosions in a confined space. Many gas testing instruments will have specific sensors for these materials. Hydrogen sulfide. Hydrogen sulfide, H2S, impairs your body's ability to breathe. It is colorless, heavier than air, will collect at the bottom of a space, and flammable. You may recognize its rotten egg odor at low concentrations, but after some exposure to it, you stop smelling it even if the concentration suddenly increases. Breathing in high concentrations can cause immediate collapse and death. Follow the link for more information on odor and toxicity. Carbon monoxide. Carbon monoxide, CO, is a colorless, odorless gas. It is a byproduct of incomplete combustion. CO is often found in the exhaust of gasoline and diesel-powered engines, including vehicles, pumps, compressors. CO reduces the ability of the blood to carry oxygen throughout the body. Breathing in high concentrations can cause collapse and death. Follow the link to other toxic gases. Some additional toxic materials that may be encountered in confined spaces are listed below. Ammonia, chlorine. Keep in mind that many chemicals, when inside a small confined space, can quickly reach levels which are toxic. Section 11. Release of hazardous energy. Another major hazard in confined spaces is injuries resulting from the release of hazardous energy. Hazardous energy is a general term covering a range of energies which can cause injuries. Some examples are obvious, such as stored electricity, the heat in a furnace, or something that might fall if not blocked. Other examples include air pressure in a system or a spring that is tightly wound. Hazardous energy may be released by machinery and equipment. Hazardous energies may include electrical, mechanical, for example rotating parts, thermal and hydraulic energies. Hazardous energies must be properly locked out to prevent unplanned accidental startup. Tools and equipment including power cords must be grounded or properly insulated and be in good repair. Lines and systems. Systems and pipes must be properly disconnected and blanked off to prevent the contents from getting into the space and possibly trapping, burning, drowning, or smothering workers inside. Case studies. Release of hazardous energy. Read some examples. Pipes. Supply lines leak into a confined space. Automatic equipment startup. An effective workplace lockout program, as well as a confined space program, are required to this energy release and lockout in confined spaces. Part 2, hazard control. Section 12, engulfment hazards. Engulfment occurs when a worker is overcome and smothered by a solid granular material such as soil, sand, gravel, sawdust, corn, grain, or flour, a liquid such as water, a slurry, oils, or other chemicals. Engulfment can cause serious injury and death when the material exerts enough force on the body to constrict or crush. Victims can also suffocate or drown. Some examples include sawdust. Follow the link to read an example. Unloading grain trucks. Follow the link to read an example. Silos containing grain, corn, etc. Fly ash vessels. Excavation or trench collapse. What went wrong? On a hot summer day, a deep sewer construction crew was working 12 meters below ground building an extension to the city sewers line. The active storm sewer was separated from the new part under construction by a 0.5 meter wide concrete plug. The crew was unaware that a severe thunderstorm with extremely heavy rain was happening outside. Without warning, the tunnel, 3 meters in diameter, flooded with water, and all 6 crew members drowned. The volume of water runoff from the torrential rain created sufficient pressure to blow out the concrete plug and flood the section under construction. The men didn't know what hit them. Always expect the unexpected. Section 13, Other Hazards. Anything that presents a safety hazard outside a confined space can also present a hazard inside a confined space. This includes a wide range of issues such as temperature extremes, noise, wet and slippery surfaces, falling objects, falls from heights, poor lighting, biological hazards. We will look at each of these briefly on the next slides. Temperature extremes. Extreme heat and humidity are often encountered in confined spaces. Extremely cold, damp conditions may be found as well. Conditions inside a confined space are often different than outside. During hot, humid summer weather, it may be even hotter inside the space. Therefore, you need to take precautions such as more work breaks, extra water to prevent heat stroke, etc. In cold situations, insulated protective clothing is bulky and will impair movement and increase exit time. Control measures must be planned and implemented before entering the space. Always be sure you know the exact conditions before entering. Noise. Noise and vibration are often amplified inside a confined space because of the shape and construction of the space. The risk of temporary or permanent noise-induced hearing loss may be increased. Appropriate hearing protection may be required. The noise can also interfere with communication between the worker inside and the attendant outside. Always check to be sure you are able to communicate and hear warnings such as air monitoring alarms. Wet and slippery surfaces. Many confined spaces are wet or humid. Walking surfaces, ladders, etc. can be very slippery. Moisture can also provide the right conditions for bacteria or algae to grow, and these can also make surfaces very slick. Wet conditions also increase the risk of electric shock. Falling objects. Confined space workers are also at risk of objects falling into or within the confined space. Spaces with a topside opening are a serious concern. Be sure that the opening is properly barricaded and keep people, loose tools, or other objects away from the opening. Inside the space, be aware of where other workers are, and be sure that all your tools and equipment are secured. Falls from heights. Remember that workers can also fall from heights within a confined space. Fall protection equipment is generally needed if it is possible that you could fall a distance of 3 meters, 10 feet or more. Fall protection may also be necessary if a fall from less than 3 meters could result in significant injury. Note, you must understand how to use fall protection equipment properly and in such a way that it does not increase the hazard. Follow the link for more information about fall protection. Lighting. Most confined spaces are dark and it can be difficult to see what you are doing or where you are stepping. Poor lighting increases your risk of injury from slips, trips, and falls. Poor lighting can also slow rescue in an emergency. Be sure that you bring adequate lighting inside the space. Explosion-proof lighting may be required if there might be flammable materials in the space. Lighting. Most confined spaces are dark and it can be difficult to see what you are doing or where you are stepping. Poor lighting increases your lighting. Most confined spaces are dark and it can be difficult to see what you are doing or where you are stepping. Poor lighting increases your risk of injury from slips, trips, and falls. Poor lighting can also slow rescue in an emergency. Be sure that you bring adequate lighting inside the space. Explosion-proof lighting may be required if there might be flammable materials in the space. Biological hazards. Biological hazards may occur from insects, rodents, bacteria, and molds. For example, spaces contaminated by wastewater and sewage. Insects and rodents may become safety hazards by distracting you from your work. Section 14, Conclusion. In summary, working in a confined space is a hazardous job. It is important to know what a confined space is, what hazards may be present, and the steps taken to control them. That conditions in a space can change quickly. that hazards are often more serious inside a space than outside, what your specific confined space entry plans and policies are. It is essential to have both appropriate education and worksite-specific training before entering the space. All of the link or